Hi everyone, and welcome to this video where we will show you how to create a face-centered cubic FCC unit cell, but this time with Z struts, but also not only with Z struts, but also it will be included a reinforced model of FCC unit cell. But later in this video we will show what does it mean a reinforced unit cell. The first goal of this unit cell, FCC unit cell, will be Z struts to reinforce whole structure with Z vertical struts, 4 struts on 4 sides of the cube. At the beginning, of course, we construct a specific face-centered cubic lattice structure in Rhino Grasshopper, and at the beginning we are running a Grasshopper tool within Rhino system, and we select a new document. So the beginning or the start of the workflow is the same like ordinary FCC unit cell, where we first introduced a number slider with boundary volleys 1 to 10, and this time we will put this volley as the default volley of the unit cell to 10 points or 10 units, and connect to new command or command we mentioned earlier. It is sensor box. This sensor box that ensures us a new box positioned in the world origin or 000 coordinates. After that, we connect it to brep box, or the construct brep, where we will have new parameters to control our major topology through faces, edges, and vertices. So we have a new, totally new setup of our whole geometry, where these parameters are allowed us to control whole structure. Because we create FCC or face-centered unit cell, we must find middle point of each of 6 faces, and for that purpose we will use area command, as we already know about it, and connect our face output to our input geometry of area. But this time I have noticed that we in this moment don't have bifocal component, a bifocals component to show all names of the components, and this kind of control our unit cell will be cell size. And now if we create FCC, we must introduce the closest points option or command, and connect this new command with vertices of our boundary representation, our centroid points, and the integer number of 3 for controlling our struts, or point on the struts to easily find their middle points. So in this moment we missed a line option or line command, and for that we will disable this preview and this preview in order to show the main frame or major wireframe of our unit cell, and we want to include this point output or point in closest to P to points where we include this and these vertices of our unit cell. So we have this situation where we have our preview of our unit cell, but don't forget to we must include our graphed model on this option graphed model, sorry, graphed model to have our ordinary face-centered cubic. So now in this moment we want to connect each corner of the unit cell in z direction, and for that purpose we introduce a box corners command and connect edges with box corners here. Now we have active or 4 points in upper and 4 points in lower or bottom part of our cubic, and we also use another line point between two points, command line, and we want to connect A output to A input and E output to B input. Now we have these 4 Z struts, and now it must be connected these two command line as one integral part through the command named join curves, and we want to make integral curve, and now all options or all conditions are fulfilled to preview and to achieve a body adding through multi-pipe command. Of course, in this moment we had a specific FCC unit cell with vertical Z struts. So we in this moment reinforce this our unit cell with these 4 additional vertical struts of our unit cell. Also, we can make a baked model. So we have here also a solid model of our unit cell, but also we can additionally reinforce our structure in some other direction, and which direction will be, we will see now if we for a moment modify this our workflow, because now if we take off or delete these comments, we are here have a situation where we want to replace or exchange the grabbed option between these two inputs, and instead of the grafting option on B input, we include a graft option on E on A on A option. So in this moment, as you can see, we have one situation where if we make a baked model, here also but we don't have a good extensions or ends in this model, so we will repair it by making a flatten uh, these ends or corners of our cubic. So if we repair it, now we have two similar but drastically similar but also drastically uh, different unit cells, because the main difference between those also but I forget also here to include a flatten option, so I can repeat it to better now our workflow. So I will return box corner and edges, connect to the input of box corner, introduce a line option, and connect A with A, E with B option, and also here we add here. So, but now we have a flatten option here as the result, because we previously didn't have this option, and I include a flatten option, and now we have all conditions to make baked model, and here yeah, but I want to make a change and graft not the A but graft our second input, of course, and now we make bake. Okay, so our corners now have a wonderful layout or wonderful transformation into regular nodes. What is the main difference? The main difference is that these corners are connected with each other corner with diagonals Z struts, which is not the case in this preview. So we have here FCC or pre-centered cubic as a base, and in this case we have additional Z struts here as additional reinforce of the unit cell, but here that reinforcement will be more detailed, more stronger, because we have each diagonal strut connected with each of the corners of our unit cell. So the best view or preview of our unit cells is here, where we can find all or be seen all differences between those unit cell. And that's it for today. I think that this constructional wireframe of the unit cell is going to be used in a way of creating periodic uniform these structures to be more stronger in additive manufacturing process. That's it. And also here is whole workflow of today's unit cell. That's it.